Good afternoon, everyone. My name is Tomas Dvorak, and I am a professor of economics at Union College in Schenectady, New York. Welcome to Project Tier webcast series. This is one of 9 webcast sessions that features leaders in transparency and reproducibility. And I'd like to thank Norm and Richard, the co-directors of Project Tier, for having the foresight of doing webcasts before everybody else was doing webcasts. I also like to thank Alfred P. Sloan Foundation for making this series possible and for continuing to support Project Tier. And I'd like to introduce our speaker today. Our speaker today is Lars Vilhuber, who is the executive director at Cornell University at the Labor Dynamics Institute and senior research associate in the economics department there. And quite importantly, he's the data editor of the American Economic Association. So he is single-handedly responsible for the integrity of all economics research. And he will speak to us today about replication and reproducibility in social sciences. And I will be taking notes of any Q&A questions that you can put on this broadcast in the Q&A tab. And I'll pose those questions to Lars at the end of his presentation. His presentation will run about 45 minutes. And I should also let you know that we are recording this session, and it'll be available on Project Tier's website. And with that, I'd like to turn it over to Lars. Lars, thank you very much for joining us today, and thank you everyone else for joining us, and I look forward to your presentation.
Thank you, Thomas, and I'd like to also thank Norm and Richard for coming up with this awesome idea of a webinar, which is a great way to get all this information in this exciting and very dynamic field out much more broadly. I'm going to talk about how we have implemented some measures to increase transparency and reproducibility in economics, starting with the journals for which I am the data editor of the American Economic Association. I'll start by saying that I wear many hats, but I speak for none of them. All of these opinions are mine, although you might occasionally find reflection of these opinions in the future policies of the data editor at the American Economic Association. So I'll start by describing a bit the background of what's driving my thought process and that of the American Economic Association here. I'll then transition into some more concrete measures and then explain exactly what it is that we're doing at the American Economic Association, but also in conjunction with other economics and social science journals more broadly. So my motivation to some extent comes from what is actually the scholarly discourse. And early publications, you might go back all the way, for instance, to the 20th century. I'm not going to go much further than that. I'm not a historian, but much of that literature already contained data. It also contained analysis. It was a lot simpler. The tables were all that there was. There rarely was microdata, and the math was simpler. You could do it on paper, and that's what graduate students might have done over the summer. As we move forward, data became electronic and was complicated in the initial electronic age, and so it was no longer included because these were tapes or these were cards or things like that, and so we no longer cited our sources in that particular way. And math was transcribed to code, again, working on various platforms and various systems using a multitude of computational platforms. And because of that, while the math might still be included, the complete expression of that math into computer code was generally no longer included, in part because it might have been transitory. So to just show you how data was included in the early 20th century, this is actually the data supplement in an early edition of the American Economic Review. And because it didn't fit on a page, they literally expanded the format to include fold-out pages and other things. We are now in a world where most of these publications are electronic. And so to some extent, the analogy of expanding the publication format to something that can accommodate the data is there. But in practice, we are still looking at glorified paper in electronic format, be it in PDF or on websites that maybe flow to our phones, but are not necessarily much more inclusive of additional information as well as presentation. So modern publications need some of the transparency and completeness that to some extent existed at a different point in time, and which we would like to sort of bring back to facilitate replicability. The discourse that the language that we speak is of, I discuss something that you did and vice versa. That's what the scholarly discourse is about. So let me take a quick step back and talk about replication. You've probably heard a few definitions over time. There are now consensus definitions that are emerging. You heard Victoria's talk to start off this series, and she was part of this National Academy's consensus study report on reproducibility and replicability in science. And the various degrees of reproducibility, replicability, generalizability are well defined there and in some other places as well. So the way that we think of this is that reproducibility, to use that term, is literally the computational reproducibility using the same data, the same code, the same methods, and the same context. You can think of it as an audit study that says what we see in the paper is actually what the data and the code provided by the authors produces. And it's designed to sort of address the question that, for instance, Michelle in her talk in this series pointed out about consistency even within publications or logical consistency of the statistics that are there. If you're producing everything by code, then those things are much harder to disguise or to fall into inadvertent pitfalls. Replicability is when you start to vary some of these methods. And I'm going to divide this into 3 buckets, but of course, there's a continuum of variations on this kind of thing. You might think about different code or software implementing the same basic scientific question. You might do some new data collection. You might actually even vary some of the methods and call it a robustness check and stick it into the appendix. And so some of this might occur within the same publication, some of it might occur in the literature. And then generalizability is when you take that basic scientific questions, we're in the social sciences, so about, say, human behavior or firm behavior or things like that, and apply it in different contexts using different methods or slightly different data, etc. And you vary all these things and you draw some fundamental conclusions about the scientific reason underlying this. To support the discussion along all those dimensions, there has been progress. So you might have heard of a reproducibility or replicability crisis. As it turns out, that discussion has been going on for about 50 years. And it's not like we haven't made any progress. It's just that some of that progress today is taken for granted. But it was not at all obvious if you go back to look at some of the discussions in the 70s and 80s. So for instance, we're going to be talking about what we've done at the AEA about replication archives and data code availability policies. Those are not novel. Those go back at least to the mid-80s. The Journal of Applied Econometrics has one of the longest running archives in economics. And in the early 2000s, a lot of the top journals announced data availability policies, which often translated into code availability policies when the data wasn't available, and put these into archives. And we're going to talk about how that has evolved a bit over time. But it also put into the same bucket of the common discourse shared open source software, whether it be partially open. In the case of economists and others, there's a lot of use of Stata, which is a commercial program, but many of the add-on packages to that are peer-reviewed, are open, are available to anybody, and the ability to share software code and source code for these kinds of things is an invention of the early 2000s, as for instance is R. So both of those are components that allow for a more structured discourse on a common denominator. It might also mean that we're all using wrong software when it turns out that one of those software pieces has an error, but as long as some of these components or all of these components are open, that is progress that wasn't necessarily available prior to that. Better public use and shared data, whether it be the open source or the open access data that many of you are used to at ICPSR and IPMT as some of those examples, or many other institutions, or some of the restricted access data at a variety of national networks that make research data available. Now that typically is not seen as open data, because of course it is not for ethical reasons and other reasons, but these networks are used by thousands of researchers, and that is far better than being used by one researcher. It is shared access to data, even if it is somewhat limited. And there are better ways of accessing preprints and great literature that have emerged over time that are now being emulated in other social sciences, but in economics and in math and physics, these networks of sharing preprints very openly have persisted at least since the late 1990s. So that's a background to a lot of progress that had been done. And so the question is, did they work? Well, the answer, of course, to that is that at least for some aspects of reproducibility, it did not work as well as designed. So this unlabeled scatter plot shows the published success in reproducing selected papers. Now, there is a lot of comparability issues in all of this, and the fact that there's multiple bubbles points to what you put in the denominator and the numerator might vary. But it is far below 100%, which was the goal of these availability policies, that these should actually help to shine a light on the methods that researchers use and keep them honest and accurate, as it turns out. The colored bubbles are from an experiment that we ourselves ran, and where we identified that depending on how you look at it, it can actually be relatively good. While you can argue that the glass is half empty, we only fully reproduced about 25% of the articles in our sample. That's in part because 40% had restricted access data where it would have been too onerous to sort of go out and seek the data, although not impossible. And another 25% of the papers reproduced at least partially the results that were in the paper. So it's a question of whether or not you think that the glass is half full or half empty, but it's a lot better than the 20% reproducibility rates that historically you've got. One key aspect is the fact that 40% of data in top econ journals is restricted access of some sort. And we'll get to that a bit later. The failure to curate was one of the incentives to why journals actually were taking care of replication archives on their own. So the idea that a researcher might be able to provide this kind of archiving on their own, as good as the will might be to provide that kind of service, it is fallible, and the lack of robustness in many personal web pages, whether it be on commercial providers or on university pages, that fragility is a problem. As it turns out, there are other problems as well. Economists, at least, I'm an economist, so I can speak primarily for those, have poor citation practices when it comes to data. You might generically describe where you got the data from, but you're not going to be very precise in general, and that is a problem. That is regardless of your specialization, whether you use macro level data or you use micro level data at the level of persons or firms. The problem is not just at the author level. There's also many data sets are imperfectly described even by the professional data providers that have them. So you may have learned in this series about the necessity to properly document the data that you have provided with additional metadata, with proper documentation codebooks, etc. Even very prominent data publishers do not provide all of that information. If you're looking for digital object identifiers, permanent keys that allow you to retrieve the data regardless of how the provider refashions its website, many providers do not provide them. And so those are problems that researchers face as well. So what to do in that kind of scenario? One aspect of it was that starting in about 2012, there was the notion that there needed to be stronger enforcement of these policies. Researchers and research institutions came to the conclusion that just putting them out there and hoping that they will self-enforce did not work. And so one of the pioneers in this was in the American Journal of Political Science, which started to enforce some of these. And as time went by, many other journals in the social sciences, in the statistics community, in the general purpose community started to put in place stronger policies and people to enforce those policies. My appointment as the data editor at the American Economic Association is the consequence of one of those reflections at the level of our association. And I was appointed, the search was in 2017 and I was appointed in 2018, but I'm not alone. Many other econ journals have started to appoint that just in the last year. There's 2 additional relatively high-placed journals that have put a much stronger emphasis on the enforcement of these policies to varying degrees. So one of the 2 methods that people have now used to sort of improve this is by verifying the reproducibility. A second direction is that to some extent, there has been a revision of data availability policies because they are broken. If data is not open access, then at least in econ, the assumption was, oh, you're going to get an exemption. An exemption from what, though? As it turns out, an exemption from documenting properly where the provenance of those data happens to be. You state to the editor, I can't give you the data, you get an exemption, and then you move on. But even if the data might be very much available, the notion that you always have to bring a data deposit is not entirely right. Because suppose that something is at the National Archives, which counts as sort of one of the gold standards of archiving. That's why they exist. Would you still ask an author who used data from the National Archives to come to a journal and deposit it? The National Archives are much more likely to persist for a longer period of time than some journals are. And so the key thing that one should actually do in those circumstances is to better describe where these data are, whether they be restricted access or even public use access. And so requiring greater transparency for data and code about where they come from and how you obtain them, etc., is one of the conclusions that our association and others have come to over this time. A final point is that to ask yourself the question, why are actually journals collecting these supplemental zip files and other things like that? Well, for one, the journal can ensure some measure of longevity. It's better than the personal website. It might not be as good as the National Archives, but they can ensure some of that longevity and persistence. They can ensure access. If you put it on the website, you can download it, although there might be a paywall there. And they can ensure availability. As long as the journal continues to exist, those supplemental activities will also be there. But that is precisely the definition of what trusted repositories do. And those are also an innovation that have emerged in the 20-teens of this century. So trusted repositories are there. It's their business model to provide persistent access and ensure availability. So one of the features of the last many years has been that there's been an emergence of a lot of self-deposit repositories that have relaxed to some extent the professional curation aspect of the data, that every piece of the data is properly documented, etc., and provide storage that is persistent with very little curation, self-curation as it's called. And whether you have them in the for-profit world, like the Figshare of this world, or the nonprofits like the Dataverse or ICPSR or Zenodo world, you can find them in the qualitative sciences. There's an excellent qualitative data repository at Syracuse. These have become almost ubiquitous and cheap for most users to do. What about those restricted access data? Well, those networks that I pointed out earlier are also serving the role of repositories. They're not self-deposit repositories, but they certainly are working in such a role, even though they might not label themselves repositories. I'll get back to an example of one of those who has taken that further along than many others in a very good way. So the idea is to use trusted repositories wherever possible, to also increase the transparency of those. The goal to some extent is use any repository. Don't move the data or the code around if it is already in a decent place. But if it is in a transient place, then the journals still have a role to play there. So the problem with leaving it in place, of course, is that you still need to assess to some extent what is a reliable place to leave these. Not every data repository is created equal. There are those that aren't even repositories. GitHubs, Dropboxes, etc. of this world are not data repositories. Anybody can go in at any point in time, delete it, or not pay their bill, and the data is gone. But even if you look at university levels, if you talk to your favorite data librarian, they might complain about underfunding of the libraries and having to cut services. And that is not something that only happens in crisis areas. It might even happen at prominent universities like my own or others out there. Are the National Archives a reliable repository? You might ask that question, and you should be able to find answers to those questions. Restricted access is the same. If you can't provide the data, then my question to you will be, well, can you describe how long the data will be there? If somebody else will go and jump through the same hoops that you jump through, can they actually get access to the data for a reasonable amount of time? So data infrastructure needs to be described. It can be described. There are standards for that kind of thing. And so once you do that, then you can actually also cite them reliably and provide a lot of information. This is not just something that's emerging in the social sciences. The notion of fair data is something that has very prominently been put out there as a new set of data principles. Fair means it's findable, accessible, interoperable, and reusable. And you can immediately see how journal repositories on one side are supposed to help with that, but also how many other institutions could make their data fair. Fair does not mean open access. It might means you need to find it. You need to be able to somehow identify its existence. You need to have some mechanism of accessibility, and that mechanism itself should be openly documented, but the data does not necessarily need to be openly documented. Interoperable means that somebody else is capable of using it using the tools so that there's some description that allows you to do that. And reusable means that, first of all, there is way to do that, that there is an access, that there is methods that are able to be deployed to reuse the data. There are also later emerging data citation principles that highlight if you are going to have fair or other data, how would you cite the data? And this goes back to the first slide that I showed you about the 1911 American Economic Review, where it was very easy to cite the data because the data was simply a couple of pages in a journal. We are now in the position where a lot of the data, but definitely not all, and I'll get to some examples, is citable because it has obtained a permanent location, has obtained a permanent identifier, has fair metadata that can be used to create such citations, and yet it is still not ubiquitous to do so. But as I'll give some examples, a lot of the data that we encounter at the AEA is actually not in a place where there is a permanent archive or where there is a digital object identifier, and yet it still can be cited and it still should be cited. So it should be obvious that data citations themselves are not enough given our normal citation standards because they tell you where the data is, but they do not tell you some of those other things such as who can access them for how long. In theory, that's covered by the data citation principles, but it's not covered in general by our citation styles. So there is such a thing called the data availability statements. They are being used more prominently by a few publishers. In other cases, they are embedded within, say, what you would call the supplement documentation, the README. That's the case, for instance, at our journal. A data availability statement answers all those questions. A statement where the data is, information why the data can't be made available or immediately available, etc. Is there some need for registration? Are there legal restrictions? Do you need to be a citizen of a particular country in order to access that? And why are those there? Is that the legal justification or is that just at the whim of a researcher? And critically, how long the data will be available? There's a statement about usage rights. Just because you can use the data does not mean that you can give the data to somebody else. And that is even when the data is sitting on your laptop. So information about usage rights and how they can be transmitted to others is one key aspect of data availability statements. So they go beyond a simple data citation. They certainly go beyond what would normally appear in a bibliography. They have to be put into a different place. So improving provenance documentation is a very big component of increasing reproducibility because it increases the entire transparency of the entire scientific work chain that we're working through. Let's take a step back and actually ask why is this actually important? And the key thing is credibility. Credibility of the person publishing, credibility of the institution publishing, of the work that underlies this. And let me take a very recent example of a study that looks at the economic and other impacts of a very long-running and very severe disease. In this case, the cholera of the 19th century in Great Britain. There are graphs in such a paper, and there are data sources mentioned for these. And so these data sources have now an equivalent citation that allow you to dig in. Where does this data come from? How credible is that data? And why should I even believe that this data is useful? Now that might be both modern data, the land registry data, as well as historical data like the Cholera Inquiry Committee of 1855. If you have access to a library that has a record of that, you can now look at that and make your own opinion. It's not just the opinion of the researcher that this is the appropriate one, but it is something that can be verified. You can now look at the data archive that goes along with this particular article. And there might be a README that identifies that that figure that I just showed you has sources. Here's the data sources and the program code sources that generated it. And we can go and find those data in that particular archive and ultimately pull up the code that constructed that graph. And now we have the entire provenance chain for that figure all the way back to the code, the data, and the data sources that went into that data. That entire provenance chain gives us some idea about how credible the statements in that article are. And now you can actually download that entire project and redo the analysis yourself. You can second guess some of the assumptions, etc. That is reproducibility, but it pertains to the initial claims that might be in such a paper. And so in particular at this time on March 20th, 2020, that is a very important thing when you see all sorts of graphics out there to assess the credibility of the information that we're basing decisions on and which we're using in various analyses. That provenance chain is key to the credibility and the reliability of any policy decisions that one would make based on the scientific evidence. Okay, what are we doing at the American Economic Association? I'm the data editor. Thomas mentioned that I'm responsible for all economic research, but it only pertains to the reproducibility of the archives of these 8 journals. We have migrated them over time into the process that we have developed under my guidance. The latest to come into the fold are the Journal of Economic Literature and Journal of Economic Perspectives, because in part they have a very different publication process. What we do is the following. We preemptively check code archives. So this happens before the paper is accepted, not at some point in time before it is published, nor after publication. We look at every code archive as it comes in and data archives as they come in. When we can, we conduct reproducibility checks. And when we cannot, because the data might be restricted access, we can reach out to other parties to do so within a reasonable amount of time. And we have successfully done that a number of times where we are not allowed to access the data, maybe because it's sensitive tax data, maybe because it's Norwegian data or something other, and where we have asked third parties to conduct the reproducibility check for us prior to the publication or even the acceptance of the article. We are also working to create better archives so that it's not just a blob sitting on a website. It is actually something that, as I just showed you on an actual example, you can peruse and download individual files, or you can download the entire thing. One comment I've gotten in the past was, well, I downloaded this 2 GB file, and as it turns out, nothing can be run because a key piece of the data is missing. That is not very good transparency, and it keeps people from actually asking the right questions. And we're emphasizing much better provenance tracking. So first of all, we'd like to leave the code where it is when that is appropriate, but document where it is. We want to leave data where it is, if that's appropriate. and we want to display that information. And display that information might seem like a simple bullet point on the slide. We're talking data citations here. All articles currently going through this work stream need to have data citations in the manuscript or an appendix or the README, but they need to have proper data citations somewhere. And it is the #1 thing that is not working in general. So the data availability policy has been out there for a number of years, since approximately 2008. What the key elements of it was that materials were supposed to be clearly and precisely documented, readily available, provided prior to publication, sufficient to permit replication, and we would post them on the AA website. What these elements actually mean is that we're now enforcing some of them and changing some others. So as of July 16, 2019, we modified that policy in a few key places. That clearly and precisely documented is vetted by me. Now there's somebody actually looking at that. We reformulated the accessibility part, that access to the data and the code must be clearly documented, and in particular must be non-exclusive to the authors. If you want an exemption now, it is because you might be the only person on earth who has access to this data. In any other way, you should, and probably must, that's a choice of the editor, provide some way for other researchers to access the data and at least describe that other way in a way that is understandable, reasonable, and accurate. And we check that. Key to cooperation, as it turns out, is to ask for these materials prior to acceptance. It is astonishing how many people care about acceptance rather than publication. And when it says that information needs to be provided sufficient to permit replication, as well as information about access to data, that is again where my team comes in. We test those things. If you tell us that the data is accessible at a particular website, we actually go and try and find that data. We check if those restrictions that you may or may not have identified are relevant, or whether they actually show up. Or most of the time, you point us at an URL and we will go and find out that registration is required, that payment is required, and we will second guess that. The other key change is that we no longer simply post these zip files on the website. We have actually migrated to what we call the AA Data and Code repository, which is a collaboration with ICPSR and which provides much greater transparency. So what do we do for preemptively checking code? Every paper that receives a conditional acceptance is verified. The data citations are checked. Are there data citations in the article? Are there data citations in the README? The quality of the README is checked. Does it simply say, oh, there's a file out there, run it? Or does it provide information on what is needed to run the file, how long that might take, what complications there might be, what edits you need to make it work, etc. We look at the quality of the code in a very heuristic sense. We look for, did you label where their table 1 is being generated so that somebody looking for it can efficiently find it? We do not, because we cannot check whether or not that particular regression method that you chose is accurately implemented or is even the right one to apply in this particular case. That's the case for the referees. That's the case for possibly post-publication discussions, even though we know from the past that they don't occur that often. But now all that material is laid out in the open for everybody else to look at and second guess. If we have access to the data, and obviously we have access to the code, we check the reproducibility of the code. The code needs to run without major manual intervention. We might change a directory somewhere, but otherwise the code needs to run all the way through. And these are not faculty level reviewers who run these. These are undergraduates who run this. So the instructions should be clear. The amount of interactions should be minimal. These things need to run. And finally, we look at the quality of the metadata in the repository, and I'll have a few examples on that. So all the guidance that we use to do that check, the materials, the checklist that my RAs work through are listed publicly. If you want to pre-check whatever your archives are going to look like, you can run through that check yourself, and you will find that we will be much happier after that. Who is doing this? I already mentioned it. the bulk of the work is being done by undergraduate students in our replication lab. Here's a list of them. These slides will also be online. So if you want to sort of hire one of these as a graduate assistant somewhere down the line, they have been great. They have received great training. These students take these articles. They're not required to understand every fundamental econometric aspect of the article, but they're required and are expected to understand plain English instructions about how you should run the code and where the data came from and what you should do to get the data. I'm assisted in this by graduate students. David Wasser was my graduate student on this until December, and Meredith is my current graduate assistant on this. The goal is to preemptively improve reproducibility. Our goal is that if somebody redid the exercise on posted replication materials appearing in the AA journals 10 years from now, that there wouldn't be, other than data access issues, that there wouldn't be much cause for concern about their reproducibility. We can't necessarily address the data access thing because there are legitimate reasons why data might not be accessible. And there are some other cases where we do not check reproducibility either, when, for instance, it takes about 500,000 compute hours. We might skip on that in the interest of time. So I already went through that. So the guidance that we've put out there, we're constantly improving it based on the feedback we get from authors who go through the process, based on our own experience with methods that go wrong or things that need to be done. So there's ample guidance. Click on the slides and you will find that. So how much do we do? These are already old statistics. In the first 4.5 months, and this was the time when we were ramping up, we did with about 10 undergraduate students, 216 assessments of 138 manuscripts. They come from all of the journals. As of yesterday, we've done about 600 assessments. Now, assessments are larger than manuscripts because if we find things that need correcting, the manuscript will go through a second cycle. And so just about every paper so far has gone through a second cycle. In general, one cycle is enough, but a few papers have proven to be particularly thorny and have gone through a second or third cycle. But that is a very small number. The turnaround is still a bit too long. We're working on reducing that. That, of course, is endogenous to the quality of the materials that we provide to authors about how they should prepare their exercises. It's not just a function of what the students have there, but we have some issues about having enough students to do this. We have grown. I'm going to be teaching the next set of trainees next week, and that is a continuing exercise. But we also leverage other services to assist us with doing this. These are appearing as on-campus or even off-campus services that provide replication services, either in general or when the data is not accessible. Author response time is, of course, also a contributor, and part of this goes back to some of the guidance that you will have received in earlier seminars in this series about what you can do to make your archives be accessible. So the greater transparency of the code goes with the data deposit that we have there. This is the type of metadata that we ask people now to fill out, so that when your project has certain geographic coverage, covers certain time periods and things like that, that information actually gets added. So at a minimum, we're improving that. You can now browse through all these data sets even before you download any single one. And all this information is posted on a searchable website. You get a project citation. There are no reasons not to cite these data, and it is linked to the publication in both directions. For the tech literati, there is also lots of metadata embedded within this that can get very arcane, but it helps us to sort of integrate with other search services such as Google Database Search. So this particular article, if you search for it on Google Dataset Search, you will now find it. Some quick statistics in Econ. Stata is by far the most popular program, followed by MATLAB. You will see very little open source at this point in time. I can detect no trend in this at this point, but hopefully that will change soon. And then finally, what do we do for provenance tracking? Well, we apply the data citation principles. These data citations are relatively straightforward. We provide examples on the AE websites. In fact, we've provided those examples for the past decade. They just haven't been typically integrated. So every manuscript is checked for the data sets that are used. Are they cited? Is there additional information on the axis? Does the URL lead to the exact data, or is it some sort of high-level website that doesn't actually help you find the data? Does the URL lead to some application procedure? Is the access procedure, complicated as it may be, described? And finally, is there a license data that is there? In fact, we can ask typically two questions. Should the author provide us with data that he didn't provide? Or conversely, is the author actually allowed to provide us the data that they did provide, even though they might, as it turns out, not have the rights to do so? We've found both cases on a regular basis, and that needs to improve as well. Authors struggle with these. That's why we have second rounds. In part, that's because some of the data providers are also not helping with this. Data providers themselves don't necessarily release the data publicly. They don't provide proper URLs, even at prominent places such as the OECD, and I pick on them because they have actually said that they're on the way to changing that. But there are also publishers that do provide that kind of thing. So for instance, the Economic Policy Uncertainty website used to have a copyright notice, but after outreach by me, they changed this to a Creative Commons, so now that you explicitly have the permission to redistribute these data. Others will still say no. Many of these start to provide robust suggested citations. Authors are encouraged to use that. And I mentioned a restricted access environment. The German restricted access environment has started to assign DOIs, permanent identifiers, to every single one of their data sets. You can download none of them because they're confidential, and yet they have fair access conditions. They have open metadata, and when you click on those, you get additional information on what it takes to get access to the data as well. So some suggestions to, as we're heading towards the end of my 45 minutes, for authors. Robust coding is so critical to the reproducibility. While your project may live for 3 to 5 years from birth to final publication, that is a long time to sort of adhere to ad hoc methods that you have to remember how to do them as well. So think of yourself in 5 years when you write that README or when you construct the code. And most importantly, we have found many cases where discrepancies show up between when we run the data and what's in the paper, simply because the author did not run the code again before submitting the paper. And so one table might have been produced 3 years ago and the other table last week. And that's when inconsistencies, such as those pointed out by Michelle in the earlier talk, show up. You've seen in Victoria's talk ideas about better replication packages such as Wholetail, CodeOcean, etc. Those are emerging. We have yet to see many of them appear. And a note of caution, the persistence of many of those platforms is not assured. Reproducibility might be good tomorrow, but the persistence of that reproducibility might be gone relatively soon. You saw in Scott Long's talk the idea, for instance, of a dual workflow. You've got data being created and data being analyzed as two separate workflows. I cannot emphasize how useful that is when you replicate the analysis. It emphasizes reproducibility from the start. But beware that you still need to document provenance of the data. For instance, if you follow the tier protocol, that's part of what you need to do there. So you need to go all the way back and document all those pieces. Streamline those replication packages. A master script is by far preferred. You have one script to run, it calls all the others, and you have run that just before submitting the paper. We can run it again, and we're not going to find any discrepancies. No manual manipulations. Don't have instructions that say, okay, change that particular parameter to 0.2 and run the code again. We have had some replication packages that had that kind of instructions 37 times. It took a long time. No manual copying of results. Use all of the software packages, have tools to write out tables, figures, to possibly integrate them directly into reproducible documents, or simply write out an Excel spreadsheet that you pop straight into your Word document if that's how you roll. There's no reason to go through a log and pick a number from here and pick a number from there. That is just a recipe for disaster. No manual installation of packages. You might think that everybody has the packages that you have. They do not. Have an install, possibly project specific. Use a script to install all of them, even when your software suggests to you nice and simple ways of, I detected you're using this package. Do you want me to install it? The answer is no. Write a script to install that same package. And above all, very clear instructions. If you can hand it to your grandma and she can understand what she's supposed to do, that's great. It's not necessarily the standard we apply. We have some trained replicators, but it should be clear at some high level of what the steps are. Don't write fancy prose, write it as a checklist, and it should be as short but complete as possible. And above all, provide data citations. It is the #1 thing that we lack in the manuscripts that we see is proper provenance description of the inputs to the papers. Most social science uses data that others have prepared for them, either directly or in some other way. There is data provenance to be identified, and whichever way you want to do that, it just needs to be clear, and we have very good guidelines for that. But there's also stuff to do for institutions. Many of these guidelines require some training. How do you do that? How do you integrate data citations with your citation manager? Where do I find a data citation when it is a thorny thing to do? So talk to your own institution, nag the data providing institutions, please give me a suggested citation, please create a DOI, all those kinds of things. The verification services out there are great, but there's a very simple verification service that you have, your students, your colleagues. If you can just hand your paper to a colleague, and even though he's overworked, he can start the program, and 3 days later, the program finishes and all the papers and tables and figures have been recreated, that is a very good plausibility check. And because you don't want to keep him too busy, keep it short. And for journals, we are working with all the other journals. What I've described is what we do at the AA, but we're not working in a vacuum. We're working with other econ journals so that whatever standard that you have when you submit to one of our journals is also acceptable at other journals. It cannot be a custom solution to a particular journal. So my Hungarian colleague called us a social science guild. We have a somewhat more modern logo. We do have a website. There's guidance there with lots of, I hope, useful materials. And if you see something lacking or something that can be improved, this is on GitHub. Find out how you can do a pull request and send us a pull request. And we want to highlight at journals better the amount of information that we're generating. The amount of information in the data availability statements can be encoded and made upfront rather than stuck into some PDF on a website, including information about tricky licenses. And with that, I'll stop. And because, of course, we're about reproducibility, you can find my archived and preserved presentation at the DOI that's on the screen. Thank you. Thomas, I'm looking at you to see if there's any questions.
Well, first of all, thank you very much. That was a fascinating presentation, really terrific. And there is a question from Sebastian Karcher, and I'll read the question. In the cholera data citation, I think that's referring to the article that was part of your presentation about 20 minutes in. One of the links was a bit.ly link. I am wondering why Lars is okay with this. It creates a black box in the provenance chain. We have to trust bit.ly, and it introduces another potential point of failure. bit.ly going out of business. To the reference, it's also explicitly discouraged, for example, by the Chicago Manual of Style.
And I agree. And these are some of the earlier articles that I can point to. They certainly aren't being admitted in some of the others. I'm not a data librarian, so some of these things were, initially we were also finding our way. So when you see this particular article, which was published in March, it probably came across our desk in our first month on the job. And so there are still imperfections. We are not perfect. You will probably also find replication archives where my RA signed off. I successfully did this, and the next person might come around and say, well, but it doesn't work for me, which suggests that there might be incomplete documentation. Maybe my RA had access to something that the other author did not. These are not perfect replication packages, but they are better than what was there before. So we're doing our best. We are refining the citation guidelines. Part of it is about getting authors to even cite that. So that's number one. And the second one is to get them to do it ahead of time so that we don't become too much of a hindrance. So we have improved our data citation guidance. It is right at the top of my list to provide even more examples and don't do's. The key problem is, how do I get people to read both my guidance and the Chicago Manual of Style? As the questioner puts out, it's right there, and the AA says it's there. But there are many elements in that chain that lead to imperfections.
All right, very good, thank you. There's another question from Richard Ball. It's a long question, and I will try to read it. 3 years ago, I thought the AEA would never do something as thorough and effective as what you have described to ensure reproducibility. So this is really inspirational. Let me ask you about another, even higher stage in the evolution of practices and norms. The vision is this: someday, creating good replication documentation is not seen as a requirement authors must meet, but rather creating good replication documentation is seen by authors as an integral part of communicating their research. So they take as much care in writing and commenting code as they do in writing the prose in the manuscript. Moreover, readers don't really think they have studied or understood a paper unless they have downloaded the documentation and played around with the data and code a bit. The unit of communication would no longer be a paper. A paper by itself would be seen as not credible. Instead, the whole package of paper, data, code, README, etc.
Yeah, Richard, long question. I see actually that there's a summarize coming after that,
okay.
where you argue that the complete replication documentation is an essential part of it. That is emerging. We do see a very large variety of packages submitted. We have everything from the one-line README to the README that really is the online appendix that goes into extraordinarily detail about how the data was done. So there's a variety of these things out there. At least in our prior work, when it did not yet have my impact on what these things look like, we did not see a particular strong impact on citations, which is a weak indicator of what people think of a paper or not. My hope is that in the future, we will see a stronger impact of that. We also are not going to see an immediate impact. Just as with the bit.ly citation that the earlier questioner had, some of these READMEs that we see as of now are still not quite as expansive as they could be. We have a template README out there, but it's not particularly easy to find. So there's communication that we need to do to craft how these stories are going to be, the same way that there's a paper template. But just as there's huge variations in papers that are passing through editorial review, of papers that are extraordinarily clear in their structure to papers that get their point across, but they're not exactly world-class prose, there's going to be differences in these various packages. We've also gotten some very sophisticated packages that essentially were too sophisticated for their own good. So there is such a thing as being too flexible, too adaptable, etc., because now you need a whole set of software requirements in order to run these kinds of packages, etc. I do think, and that is my vision, that these become more integral to how people think about it. That there are technological requirements that the publishing platforms that we use are going to be on. You can see some of the high-profile commercial publishers start to think about more dynamic publishing platforms, and yet I still think that they don't necessarily go all the way. But again, there's a careful balance here of, are you going to write for the one platform that is highly sophisticated, and you're going to adapt your paper to that platform, or do you have a paper that can find publications outlet in a variety of outlets without huge effort by authors, right? What happens if you write for that extraordinarily sophisticated platform and you get rejected? And now you're supposed to provide a Word file. There's a balance between those two in getting authors to actually consider that as something, because you can't do this after the fact. You have to do the kind of structuring right from the start when you set up the project. Take the tier protocol, take what Scott described, take our template on doing these kinds of things. You have to think about them right from the start. It's not something that you can easily or costlessly craft onto the end. So there's a variety of factors that work into how we can highlight these kinds of things.
Very good. Thank you. There's another question from Dorothy Bishop. How many errors do you typically find in a script?
That's a good question. We actually could provide an empirical answer if I could get my RAs to consistently use the same methods that we ask authors, that suggest authors that do. But my RAs are also not infallible. We do actually track the original package from the authors and then the changes that the RAs implement in order to change the programs to something that works. And then we can identify from that, they made reasonable changes and yet it still doesn't produce the answer, then it goes back. So both are dirty indicators of how many changes one needs to make. And we see everything in terms of computational code that can or needs to be changed. But other than getting code to run, we have seen almost no examples where the numerical differences, once it ran, were of any particular significance. So our focus really is on getting the programs to run and much, much less on identifying severe problems in the underlying empirics that we find. That is somewhat surprising, at least from my perspective when I started out. I would have thought that we would see more issues there than we actually do. But of course, there's some endogeneity in that because they know that somebody's watching. So the worst case scenarios that we've seen is that we find numerical differences, say in the count of observations in a particular subsample, because in newer data, there were some additional cases added or removed. And those are ultimately solvable by proper provenance documentation. Or we tell the author, look, update your tables again. And if we think that there's a change in the conclusions of the paper, if we haven't even have that suspicion, I can always send the paper back to the paper editor. We have never done that. In all the 600 assessments, we have not had to send something back because it radically didn't provide even anywhere close to the right answers or in any way change the conclusions. That is reassuring. It is surprising. It is almost certainly not reflective of economics in general. These are relatively high profile journals that I'm working for, but it is good to know.
Very good. Thank you. We have 1 minute to spare, but let me ask you then a sort of quick question. The ultimate goal of these efforts is scientific integrity. We want to make sure that the results that we see in journals are the truth. If someone says that taxes matter for labor supply, we want to believe that, and certainly making sure that code runs is definitely the first step. But I could easily imagine writing a code that runs, from start to finish. But inside that code, I can put in all sorts of if statements to make sure that I get the results that I was looking for.
Right.
And so having code that runs, I certainly know that you're aware of this. That's not the ultimate measure of integrity. And so how deep then do you go into the code? And then is it the role of the referee to see, oh, well, look, you eliminated Alaska from the data, but you don't say that in the paper, and the readers might interpret the results differently if you pick and choose certain observations, and
there's in my vision, where we are right now is not ideal. We're at the conditional accept stage. So the referees have done their job and they're not going to see the paper again. They didn't see the code. In our ideal scenario, think of this as the endogenization of the final check. If you know that your code is going to be checked at the end and that it could delay the publication. You've had some people who are nervous about the delay that we were introducing to this, both editors and authors. Then you're going to internalize that and have code that runs ahead of time. Ideally, we would also have that code available to the referees. There are other journals and other disciplines that provide the code to the referees. Now, the first answer I get back often on that is that referees are already overworked. They're not going to have time to look at this, so that's not worthwhile. And my response to that is it's an option. And whether or not a referee does it or not is a personal choice of the referee, is part of their technical capability. Ensuring that when you do that, you don't have to worry about debugging the code first is, I think, a very important aspect to the efficiency of even considering that. If it takes me a day to debug the code, and then I can start asking questions about the if-then statements that you put in there and how they reflect with it as I play with the data, I'm not going to do it. But if I already know that the code does run, then I can actually play around with, as Richard mentioned in his comment, I can play around with these analyses. Right. As a referee, prior to publication, I can provide comments back. Okay. Some of the best referee reports I've done have more or less redone the work that I did because the author actually invested in doing it themselves, replicating, not reproducing it, because I had no way of communicating my code to them. And so there certainly is value in that as well. But the other aspect is that post-publication, there are now methods that you can use to do that. We have now put all the code out there. The replication package has no big problems. It is known to run in at least one additional instance when we can do that. And we've sort of looked at, is it complete enough? Are there indications that it's there, etc. Authors can actually, on our new platform, also publish subsequent versions. There will be a version of record that's associated with the published article. But even on the Open ICPSR platform, the authors by themselves can publish version 2, 3, 5, 8, 10 that reflects comments made by others. How good that documentation is, how good that outlining of why they reacted, why there is a new version, etc. Well, have a look at commit messages on GitHub and you'll probably not be very positive about that because they tend to be very curt and short. But one domain that I know a bit about is the literature on minimum wage. And many of the discussions on that have been about sharing data and discussions about choosing the right sample and making the right decisions, because both sides of the discussion had code that was fairly reproducible. We're trying to accelerate that process by not even requiring interaction between the authors, but by putting the information straight with the article in a way that is very easy to do.
Very good. Well, thank you very much to Lars Vilhuber. Thank you to all the participants who tuned in to Project Tier's webcast series. And I believe there is another 2 or 3 webcasts coming up. So please check Project Tier's website, and have a great afternoon and great weekend. Goodbye.
You too, and stay safe.
Thank you. You too.